Hello and welcome to helpyourmath.com. In this video on division of polynomials, we're going to look at dividing polynomials by monomials. How do we divide a polynomial by a monomial? Well, we divide the denominator using the distributive property into each term of the numerator and simplifying the terms separately. And then all exponents should be positive. So if we have a plus b plus c divided by d, we take d and we divide it into each of the terms that are in the numerator. So we would have a over d plus b over d plus c over d, and then we would simplify each one separately. Now, this could also be subtraction. So it could be a minus b minus c, in which case it would be a over d minus b over d minus c over d. And reminders of some exponent rules. One thing when we start dealing with a lot of variables is we then just apply the properties of variables to everything. But when we simplify numbers, we simplify by canceling out common factors, right? So if we have 6 over 15, we don't subtract 6 and 15. We would say, wait, those both have a common factor of 3, and we would divide them both by 3, giving us 2 over 5. And also, if we have the same variable in the numerator and denominator, how do we simplify? We subtract the exponents. And what I like to do, instead of strictly subtracting the numerator by the denominator, the exponent of the numerator by the exponent of the denominator, in order to keep the exponent positive every single time, the result will go in the position where the larger exponent was. So if you have more factors in the numerator, then the result will be in the numerator. If you have more factors in the denominator, then the result will be in the denominator. Okay, so just to practice these, reminders that we just talked about, let's simplify each of the following. Write the answer using positive exponents only. So in letter A, we have x to the 6th over x squared. So we have 6 factors of x in the numerator, and we have 2 factors of x in the denominator. We have more factors of x in the numerator, and what we would do is we would say, okay, it's going to be 6 minus 2 over 1. And that would just be x to the 4th over 1, which we could just write as x to the 4th. Dividing by 1 doesn't do anything. It's a identity, so we would just have x to the 4th. In letter B, so here's what I'm talking about where we want to be careful. We have more factors of y in the denominator. There are 13 factors of y in the denominator. There are 5 in the numerator. So what that would do is we could say 1 over y to the 13 minus 5, and then we would have 1 over y to the 8th. So if you keep the base where the exponent is bigger, then you're guaranteeing that the exponent will stay positive. If you choose to use the subtraction where you just do 5 minus 13, then you get y to the negative 8. That's fine, but it does say write your answers using positive exponents only, so you're creating one extra step for yourself. Okay, how about letter C? So letter C, we're going to focus on the same basis. So I'm going to look here. I have x over x cubed. This would be x to the 1st. So I have 1 factor of x in the numerator. I have 3 in the denominator. That means I have 2 more factors of x in the denominator. 1 would cancel out. Here I have 4 factors of y in the numerator, and I have 11 factors of y in the denominator. I have more in the denominator, so there's going to be a base y down here. How many more? Well, 11 minus 4 more, so that would be y to the 7th. The numerator is now empty. We're going to need to put a 1 up there. Notice that when the numerator has a 1, it stays 1 over. It's when the denominator has a 1 that you can get rid of the fraction altogether. And how about letter D? So letter D, we have, oh, how convenient, 6 over 15. What a coincidence. So 6 over 15, again, we simplify those like the numbers that they are. They both have a factor of 3, so this would become 2 over 5. So what we're dealing with here is going to be 2 over 5. Then we have 16 factors of a in the numerator, 12 in the denominator. There's more in the numerator. How many more? There are 4 more. So 12 would cancel. We would have 4 left in the numerator, and then b to the 5th in the denominator. And that would be simplifying with practicing. Now let's actually look at using the distributive property for division. So we're going to simplify by distributing the denominator to each term of the numerator. Write your answer using positive exponents only. How many terms are in the numerator? 1, 2 terms. So how many times am I dividing by 6m to the 4th? 2. Keep hitting the button by mistake, sorry. So I would have 12m to the 6th over 6m to the 4th minus 6m to the fourth over 6m to the fourth. So we distributed the denominator. Now we're going to simplify each term separately. Here we have 12 over 6, that would be 2. And we have 6 factors of m in the numerator. We have 4 in the denominator. There are 2 more in the numerator. Because the denominator turned entirely to ones, we can just write it as 2m squared. The second term, so minus, oh look, the 6's cancel out and the m to the fourths cancel out. So what's left? Well, that would be 1 times 1 over 1 times 1, or 1 over 1, or just 1. We need to include the 1. It's not an identity when it's addition or subtraction, so there should be a second term here. And a good rule of thumb is when you are dividing polynomials by monomials, there will always be the same number of terms in the answer as there are in the numerator. So I have 2 terms in the numerator. My answer should also have 2 terms. We want to be very careful of that. It's really easy to just say, look, that just, it cancels, it disappears, but it doesn't completely disappear. All right, how about this one? We have a squared minus 2ab minus b squared over ab. How many terms do we have in the numerator? 1, 2, 3. How many terms will be in our final answer? That's right, there will be 3. In the meantime, what we're going to do is we're going to divide all 3 terms by that denominator ab. So we're going to say a squared divided by ab minus 2ab divided by ab minus b squared over AB. And you'll notice here, what I put in between each of these now separated terms is what I saw in the numerator. So I saw a subtraction, so I put a subtraction here. I saw another subtraction, I put a subtraction here. So that's where those signs came from. Now we're ready to simplify each term separately. A squared over AB, let's see, there's 2 factors of A up here, there's 1 down here, so that 1 will cancel, leaving this first term as A over B. In the middle, I have 1 factor of A up here and 1 down here. Those cancel. 1 factor of B up here, 1 down there. What do we have left? Minus 2. And then here we have B squared over AB. I have 2 factors of B in the numerator, 1 in the denominator, so 1 will cancel, leaving me with minus B over A. And I don't know what the rule of thumb is in terms of writing the final answer. I see some textbooks will put all of the terms that have any variables at all first, and then put anything without a variable last. Personally, I don't think it matters. It's not a big deal to me. I would just leave it like this. Don't create more work for yourself. All right, do you think you're at a good spot to try this one on your own? I think you are. How'd you do? How many terms are in your final answer, first of all? If you said 3, you are correct. If you said anything else, especially if you said 2, no, you lost a term. There are 3 terms in the numerator, 1, 2, 3. Each of those terms want to get divided by negative 4xy squared. So we're going to write this as negative 14x cubed y squared divided by negative 4xy squared minus 4xy squared over negative 4xy squared plus 12x divided by negative 4xy squared. And again, the sign out in front is the sign from the numerator, and then notice each time I divided by negative 4xy squared, so we want to make sure that we're consistent with that. Okay, we're going to simplify each one separately now. In the first term, negative divided by negative will be positive, and 14 over 4, well, we can't divide 14 evenly into 4, but they are both divisible by 2, so that would give us 7 over 2. Then we have 3 factors of x in the numerator, 1 in the denominator, so we're going to have 2 factors of x remaining in the numerator, and the y squares will cancel out. So our first term is 7x squared over 2. In the middle, we have a minus and a negative, so 2 negatives will turn the middle term positive, and then the 4's cancel, the x's cancel, the y's cancel. So what do we have left? Say it with me now. We have a 1. It does not go away. We do have that 1 there, right? Because when I say cancel, I really mean that everything turns to 1s. So it's like 1 times 1 times 1 over 1 times 1 times 1. That's 1 over 1, which equals 1. And again, with addition or subtraction, you need that 1. It's not an identity for addition or subtraction. How about the third term? We have positive divided by negative, so this is going to be negative. We have 12 over 4, which is 3 in the numerator. Because, right, we could do this, 3 and 1. X and x will cancel, and there's no y's in the numerator, so the y squared stays in the denominator. So here's our final answer, 7x squared over 2 plus 1 minus 3 over y squared. And our final example, again, I encourage you, pause the video, see how you do. How many terms are in your final answer? I hope you said 4, because you would be correct. There's 1 term, 2 terms, 3 terms, 4 terms that are getting divided by 12m to the 4th n. So we're going to divide each one separately. We have negative 16m to the 6th n to the 5th over 12m to the 4th n minus 24m to the 5th n squared divided by 12m to the 4th n plus 48mn squared divided by 12m to the 4th n plus 1 over 12m to the 4th times n. Simplifying each one separately, for the first one I have a negative over a positive, so it's going to be negative. 12 and 16 have a common factor of 4. 4 goes into 16 4 times, 4 goes into 12 3 times. So we're definitely just having a fraction in this first term, 4 over 3. For the m's, the base m's, I have 6 factors of m in the numerator. I have 4 factors of m in the denominator. There are more in the numerator, so my base m goes in the numerator, and there are 2 more. So 4 of the factors of m will cancel in both the numerator and denominator, leaving me with 2 factors of m in the numerator. How about the n's? I have n to the 5th over n to the 1st. There's more factors of n in the numerator. How many more? There are 4 more. So we would have negative 4m squared n to the 4th over 3 as our first term. Our second term, negative divided by positive is negative. And we have 24 and 12 are both divisible by 12. 12 goes into 24 twice. It goes into itself once. So we have a 2 up top. Then we have 5 factors of m in the numerator, 4 factors of m in the denominator. There are more m's in the numerator. So this would be m. There's 1 more, right? Because 5 is 1 more than 4. And then we have n squared and n. There's more factors of n in the numerator. How many more? There is 1 more. So I created a fraction bar, but really I didn't need to, right? Because the entire denominator turned to 1s, and dividing by 1 is just going to be whatever's in the numerator. So that's going to be minus 2mn. Okay, moving on to our third term. I think this one we actually do need the fraction bar. 48 goes and 12 have a common factor of 12. It goes into 48 4 times. It goes into itself once. So we have a 4 in the numerator. Our m's, I have 1 factor of m in the numerator. I have 4 in the denominator. So I have more factors of m in the denominator. How many more? There are 3 more. What about n's? I have n squared over n to the 1st. I have more factors of n in the numerator. I have 1 more factor of n, which I don't need to actually put the 1. So that third term becomes 4n over m cubed. The last term we're not going to be able to do anything because it has a numerator of 1, so we're just going to copy it down. 1 over 12m to the 4th times n. And this is our final answer. These have been examples of dividing polynomials by monomials. Thank you for stopping by.